Today we're going to be talking about multiplication strategies for multi-digit numbers, and we're going to be learning about 3 different strategies that we have gone over here at school and that students should be familiar and comfortable using. The first strategy that we're going to do is called the area model strategy. We'll also be doing a strategy called expanded notation. And a strategy called algebraic notation. I'm going to switch markers real quick. This one is dying on me here. All right, so the strategy that probably will be used most frequently by kids will be area model, followed by expanded notation. But algebraic is something they need to be familiar with, and if they saw an equation that looked like that, need to be able to kind of understand and interpret it. So these are multiplication strategies. In 4th grade, we will be learning to do 2-digit by 1-digit multiplication. So that would be a problem that would be 23 times 7. And we will be learning up to 3-digit by 1-digit, which will be the example problem for today that we're going to do. Let's say we're going to do 147 times 6. Okay. That is the highest that they will need to go, but they will, if they wanted to do a 4-digit by a 1-digit, they could use any of these strategies. Coming up further in this unit, we will be doing some 2-digit by 2-digit, but I'm going to save that for a separate video. 2-digit times 2-digit. So that would be example of 25 times 31. But we're going to focus on 3-digit by 1-digit today. So when we do multiplication in 4th grade, we are not using the standard algorithm. We are using one of these 3 strategies. If students know the standard algorithm for multiplication, they are welcome to use that to check one of these strategies for accuracy. So let's start first with the area model. One of the important things to know when we are doing any of these strategies is we're focused on place value. So students need to know they have 100, they have 4 tens, which is a value of 40, and they have 7 ones, which is a value of 7. Because in all of these strategies, we break down that 3-digit number into its place value. So I even kind of show them underneath or encourage them to write it underneath 100 plus 40 plus 7 to break it into its expanded notation, because that we are going to multiply in sections or in chunks. And then for the area model, it brings us back to the idea of finding the area of a rectangle, which is length times width. So we are multiplying all the way through. We multiply whatever's over here by whatever's over here. A multiplication sign right there if that helps students remember. So when we take a look at this, because I have 3 digits by 1 digit, I need to break my rectangle into 3 sections, because I'm going to have a 100 section, a 10 section, and a 1 section. And then what we do is we go ahead and we label those 3 sections according to how many hundreds, how many tens, and how many ones I have. So 100, oh, it's a little messy, 40 plus 7, and then the 6 goes down here because we have 1 row of 6. So now we're going to find the area of this rectangle, of the middle rectangle, and of the end rectangle. Those are all going to be called partial products. We're finding part of the product, and then what we do is join them together, add them, to then find the total product. And so what students have been taught to do is that they go 6 times 100, and they actually write that equation right in the box. 6 times, breaking it into parts like this makes it a little easier to find those products. 6 times 100 is a pretty easy equation for most of us. Then we do 6 times 40. We have talked in class that if we know 6 times 4 is 24, if we have 40, that means we have, actually we add that 0 back on, we have 240. And I often encourage students to box that 0 as a reminder there. And then finally we have 6 times 7, which hopefully is a known fact. If not, they just can do some skip counting and some adding to get their 42. So now we have 600, 240, and 42 as my 3 partial products. To get my final product, the answer to 147 times 6, I need to put them back together with addition because I kind of decomposed with addition. So over here off to the side, we can add 600 plus 240, making sure we line up all our values again, going back to our addition strategies. And we have 2, 8, 8. So the final product here should be 882. This is how the area model will look. This will be probably the model that most students choose to go and use most frequently. Now if we can do the area model, we take what we know about the area model and we use it to help us with expanded notation. You don't not have to do the area model first to do expanded notation, but I encourage you to see the connections as we work through this problem right here. So again, we're doing 147 times 6 equals, okay? And so for expanded notation, we are going to use this right here again, this idea of these values. So we're going to write 100 plus 40 plus 6, and we're going to show down here that we're timesing, oh, I'm sorry, that's a 7 times 6. Kind of rewrite the 3-digit number in expanded notation, and then we times 6 on the second row. So we can see the connection right there that we have. We're not drawing the rectangles, but in a minute you're going to see these same partial product equations. So that 6 needs to get multiplied by all 3 parts. It needs to get multiplied by the hundreds, the tens, and the ones. And so what we do is down here we go ahead and show 6 times 100 is 600. Then we show 6 times 40 is 240. And then we can show 6 times 7 is 42. And then if I've lined them all correctly, I can add them back together right now and go ahead and get 2. 4 plus 4 is 8. 6 plus 2 is 8. I get that same product again. 147 times 6 equals 882. And all of these connect back to the area model. Each equation connects back to that original model. And this is the order the kids will be introduced to them at school. So they will be able to keep going back to the connections between the models. Then algebraic notation is just a little more algebra, also known as the distributive property, that if you're familiar with that, you'll see that here. Again, 147 times 6. And what happens here is we just show it more with algebra symbols like parentheses and a variable, and I'll show you what that looks like. Again, we're decomposing 147 into its place value. 100 plus 40 plus 7 parentheses, and then we are going to do times 6 equals n. And in this model, they don't need to write each equation out, it's a little bit more work in your head, but the distributive property says if this is in parentheses that this 6 needs to be distributed to all the places, which is basically what we did here. Every single place got multiplied by 6. Here, it's just more equation based. So the students would show that now 6 times 100 is 600, plus 6 times 40 is 240, plus 6 times 7 is 42 equals n, and then they would, 800, they could rewrite it vertically if they needed to, equals n. So this is just showing it in that much more algebraic way. These two strategies are a little less work in your head. They actually see the equation that they're focused on. I think students in 4th grade have a lot more success with these, but we also want them to be familiar and start to see this connection here. And then all 3 of these models in 5th grade, you'll see them use the standard algorithm, and all of the steps in the standard algorithm begin to make sense. We're not just listing steps for them to do, but students are understanding why we drop a 0 and we do different things when we're using the standard algorithm for multiplication. I apologize for my scratchy voice. We're still week 2 and we're still a little scratchy, but hopefully you made it through to the end of the video and you can have a better understanding of what we're doing with multiplication in class. Remember, 2-digit by 2-digit will be coming up in a separate video. And then 2-digit by 1-digit is basically the same as this, but you would only have 2 boxes. All right, you would have 20 plus 3 times 7 over here. Here we have 3 boxes because it's a 3-digit number. And if you had a number in the thousands, it would be a 4-digit. All right, I hope that helps a lot. And be on the lookout for that next video next week.